The landscape of northeast Wales is just breathtaking. But here you'll also find the biggest manufacturing site in Britain.
For me, its beauty lies in its industry. Just look at this. It's just stunning what's produced here.
For over 7 decades, Flintshire has been at the centre of Britain's aerospace industry. And some of the planes built here even broke world records. The world is watching North Wales again as the engineers here revolutionise air travel as we know it. They create wings for some of the largest aeroplanes to fly in our skies, and their latest A350 has a groundbreaking new design. To find out how they're doing it, I'll be joining the team assembling one of these wings, uncovering the surprising secrets of their engineering along the way.
Stunning, just stunning.
And finally, the ultimate test. I'll fly on these Welsh wings to discover whether their innovative design is helping to create the quietest and greenest commercial flight ever.
Do you really like flying this plane?
Oh, yes.
Do you?
November 242, Charlie Victor, Hard and Sarah. Good morning again. Join crosswind and report left-hand downwind runway 22, the QNH and the QFE 1012.
I love the North Wales coast. Just look at that view. I grew up in Prestatyn, and I used to sunbathe on that beach down there and look up and see the aeroplanes coming in and out of Liverpool Airport and think, one day I want to fly a plane. It's taken me a long time to get there, but now, here I am. Hello, Prestatyn.
All that I want is a pair of wings to fly.
On radar, November 242, Charlie Victor. We are 11 miles to the northwest. Request joining instructions.
I've recently qualified as a pilot, fulfilling my childhood dream. And this is the first time I've ever flown low over my home patch.
What I didn't realise when I was growing up is that North Wales is one of the hubs in the world for aeronautical engineering. And down there is where they build some of the best parts of aircraft in the world.
Airbus Broughton is located on a massive 750-acre site in Flintshire. Here they build wings and then transport them on this extraordinary plane to the south of France. Everything they do is on a gigantic scale. And their latest groundbreaking design is taking the aeronautical world by storm. My little plane isn't as big, but she's just as loved.
November 2, Charlie Victor, runway 22.
I'm flying in to find out how these brand new wings are setting a new benchmark standard for fuel efficiency.
You're parking on apron Bravo with the Beluga. So once runway vacated at Bravo, if you follow the marshal's instructions.
It's cutting edge stuff. We may never fly in the same way again, and it could all be down to some Welsh wings.
Broughton is famous for building wings. The wings of an aeroplane are critical to how the plane flies, its handling and its fuel efficiency. And this year they're celebrating 75 years since production first began on this site. Today they're supplying some of the most popular airlines in the world, and that keeps around 6,000 Welsh workers busy. And I get to join them.
So you're the man in charge here.
Yeah, it's good to see you here. Welcome to Broughton. This is where we build A350 wings. The A350 is one of the most advanced aircraft in the world. It's made of advanced materials. 70% of the product is advanced materials, and 53% of that is carbon fibre composite.
Carbon fibre is a form of soft graphite, just like what's found in the centre of a pencil. It's mixed with plastic resin to make carbon fibre composite. It's tough, lightweight, but extremely flexible.
We're currently building 1 pair, 2 pairs per month, but by the end of this year we've got to get to 5 pairs per month.
Within a year?
That's a 5 times increase, that's correct. I understand you know a little bit about engineering, Carol.
Compared to you, about that much.
Would you like to join us?
I'd love it. I really would love it.
Okay, great.
The moment has come for me to get hands-on experience in building one of these wings.
This uniform reminds me of when I was a very junior engineer at the De Norwich Power Station in Snowdonia. And of course we had the capped shoes or boots, the boiler suit or overalls, and the obligatory hard hat. Yes, sir. They call this the washing line, and you can see why. Except here, we don't have clothes hanging down. We have the skins or the covers of the wings. This is the top cover, and this one here is the much more curvy bottom skin. What's so remarkable about these is that they are the largest single pieces of carbon fibre composite ever made in the world. And that gives you some indication of just how revolutionary this place is.
Good afternoon, Station 82. So to start with, safety, okay, no near misses, no accidents.
It's the start of shift, and we're all lined up for the team briefing.
Some of us will be supporting MSN 25 removal from jig. Any issues? Right, thank you very much, guys. Have a nice afternoon.
Just take that with you.
My first job is to move this 2.5-ton carbon fibre top skin of the wing into the jig so we can work on it. To manoeuvre it around the factory, we're using a special vehicle known as the AGV.
Hi, Carol.
Hi,
Your turn
Rusty.
to shine today.
All right then.
You going to help us out?
Yeah,
Moving this
moving
panel?
moving the cover.
Going to move the cover today?
Is that for me?
Yep.
Hope it's the right size. I have got my certificate in
Good.
forklift truck driving. It's
Well,
not quite the
that's
same,
not
is
going
it?
to help us today.
So put this around my waist.
This is the
do I?
box. This is the dead arm box.
What does that mean?
My colleague's going to be driving.
What does a dead arm box mean?
Whatever. If there's a problem and we're
Yeah.
swinging and
Yeah.
we're coming to a bollard, if you think it's unsafe,
Yeah,
take your hand off that
yeah.
and the machine, AGV will
Just
stop.
cuts out.
Cut out straight away.
And that's worth millions, isn't it?
I'd guess, I think possibly 1.1 million, 2.
Yeah.
So,
1, 2.
that's only.
It's only
It's
carbon
only money,
fibre,
isn't
eh?
it?
It's only money.
So, Eddie, good to go.
Right, I'm sticking with you, Ross.
Yeah.
This is brilliant. The way this
And this
moves.
is stuff. It's fantastic.
These wheels are incredible.
And I think it's roughly about £8,000 a wheel.
Is it really?
Yeah.
This is an extremely delicate manoeuvre, and you can feel the pressure. The team knows that one false move could cost a fortune.
Take your hand off now. It stops straight away. It's looking like possibly may have to move this
Move this.
frame.
This AGV not only manoeuvres, but it can also lift this heavy and expensive piece of wing.
You're going over the top.
The first flight.
It's like, yeah.
Luckily, it has just enough reach to clear the frame.
It's been designed by the Americans, is that
I
right?
think that's German. Kuka, I think Kuka's a
Say that again. What was it?
German. Stan Borden.
I know, yeah.
The next stage in the manoeuvre is to lift this delicate top skin right up to the ceiling of the hangar and then across to the jig. The frame uses 103 vacuum suckers, just like the suckers to hold your cuddly toy in the car, but just a little bit more powerful.
I feel as though I'm attached to this wing now. Some kind of ethereal way.
Go on, Carol, give it a full whack.
Bit of welly.
Yeah, give it a bit
Go,
of welly.
baby, go! Woo. She doesn't swing as fast then,
No.
does she? She's good.
The quicker it's in the air, it's safer.
But she's safe, tidy up
She's
there.
safe, she's not swinging, and she's happy to be drove in now with no problems. So I'm going to take it into the jig now,
Yeah, go on.
and then we're going to lock it down.
All right, I'll hold your paper.
Thank you.
While I leave Rossi with the tricky job of positioning the top skin, I'm going underneath to get my hands dirty and come face to face with those carbon fibre wings.
All right, boss, what we're going to do?
Basically, the machine comes in, drills all the level cover, but it can't get in this area because it clashes with cantilever.
The pressure is on me now to drill a perfect hole. The drill I'm using here is powerful, and to stop costly mistakes, it's completely automatic. Perfect. One down. Several thousand to go. Although I've got a sneaky feeling that someone's drilled some already.
That's it. Good hole.
Thank you very much.
Choosing carbon fibre composite over old-fashioned aluminium has meant huge changes for the workers here.
I mean, the thing is, for someone who's a passenger, what it's made of is so completely different, isn't it? The kind of the cleverness is hidden almost.
Yeah, it's
from a
so alien
passenger's
to
eye.
us, it's just metal. We've
Yeah.
worked with metal for so long, and now it's all of a sudden it's just a different.
It's like NASA.
It was like going from
like NASA
It's like
to
going
us.
from the cave to NASA. It was. We were like cavemen. Cavemen to astronauts in a week.
Failure is not an option.
Working with carbon fibre has completely changed how the wing can be shaped. The curve in this panel could mean cheaper fares for everyone, as it reduces fuel burn by 25%. To understand how, I'm going back to the basics of flight.
It's the wing that gives us lift. Now, I'm going to show you just with a little drawing about how it works. So I'm going to draw my wing here, and generally on a wing, the curvature on the top of the wing is greater than on the bottom, and there's a reason for that. So this is my airflow. So when a wing is moving through the air, you see that a dot on this bit of air coming over has to go all the way over the top of the wing. Similar dot just travels underneath, and then they meet up at the back and then on they go. Now, the thing is, when this one going over the top of the wing travels, it has to go faster than the bit of air on the bottom. So what you get is you have high pressure on the bottom, low static pressure on the top, and the high pressure pushes the wing upwards, and that is the force that we call lift. Or, when you're looking at an aeroplane, I call it magic.
It doesn't matter if it's a jumbo jet or a bumblebee. They each achieve lift in the same way.
Now, if you don't believe me, you can do this at home. Get a bit of paper, okay, static pressure the same, the weight of the paper is hanging down. When I blow across the top, the pressure on the top will reduce and we will have lift. You see?
But once in the air, the shape of the wing determines the way the aeroplane flies. The best way to demonstrate is with a bit of aeronautical origami.
I think you're a bit of a neater folder than me.
Oh, is that what it is? You're after speed.
And as a former fighter aircraft designer, Roy Scott knows all about it.
One of the main principles is the angle of the wing relative to the fuselage,
Yep.
the body. So, for example, here, what we're looking for is a very stable flight on a passenger aircraft. What we do is slightly fold the wings upwards to give that upwards effect, and that's called a dihedral wing
Dihedral,
effect.
that's-
Dihedral effect.
P-wings.
Yeah.
Yeah.
And the Harrier jump jet, for example, where we want an unstable aircraft because it can roll
You
fast.
worked on that as well,
That's
didn't
correct,
you?
yes, down
Yeah.
in Farnborough. The wings are formed downwards in an anhedral effect.
So if you look at fighter aircraft, you can see that.
Yeah.
Okay.
So mine theoretically should go the furthest.
And mine
more
should do
smooth.
the rolling and spinning and all of that.
Okay.
3, 2, 1. Yes! Yay!
So yours was spinning
It's
quite a bit.
spinning, yeah.
Mine somehow nosedived. So maybe there's a secret paper clip in there.
Yeah, that's what it was.
Airbus is one of the biggest employers in Wales. Building wings keeps a workforce of over 6,000 busy. There are currently only a few completed A350s in service, but the pressure is on to supply 780 pairs of wings on order to customers such as Qatar Airways. But this factory has a long history of working against the clock.
This is a bomber factory in Britain. The workers have arranged with their management and their joint production committee to build a bomber in the record time of 30 hours. The clock strikes
This is
9
Broughton
and
back in
the record-breaking attempt
1943.
begins. 2 sections of the fuselage.
Here, a team from the factory are attempting to set a world record to build a whole Wellington bomber aeroplane.
You can get some idea now of the size of the bomber. It's almost 65 feet long.
During the Second World War, while the men were fighting on the front line, women were clocking into factories all over Britain to help in the war effort.
The progress they are making speaks for itself. For it's only 10 o'clock, 1 hour from the starting time.
Betty Weaver was one of the women trying to smash that world record. She was recruited to work here from the local co-op. She's 94 now.
The first day I turned up, there was 2 of us together. We had our photograph taken to put on a pass. I was under the largest white boiler suit I've ever seen in my life, and a wooden box with tools in it. And I didn't know which one to use or which end to start, but I was thoroughly taught for about 3 weeks.
Yeah.
And that was it, I was on my own.
So here was this massive production line, and little Betty...
Big Betty.
So which job were you given then, and the whole construction? What was your job on it?
Well, it was the intercom inside the plane, where the crew kept in touch with each other.
Okay.
2 ladies before me used to run the cable through the plane.
Yeah.
And there was a box of fed at each station,
Yeah.
so that the pilot could keep in touch with all his rail
crew,
gunner,
yeah.
the navigator, the wireless operator, second pilot, and I connected the boxes up.
And did that remain your job through
Yes,
the war then?
all the way through.
So everybody specialised in one
Exactly,
thing?
yeah.
Because the wings and the fuselage were fabric, weren't they?
Basically, yes.
The cover of them
Yes.
was fabric.
Yeah, it was linen that they stitched on.
Yeah.
And they had to do 12 stitches to an inch.
And that's
if there was 1 stitch missing, it had to be undone
No.
and redone. Yes.
Yeah.
And then it was doped over the top until it was like the skin of a drum, more or less.
Really
that sort of thing.
hard.
Yeah.
And so the inspectors
Very,
checked all
very
that.
strict.
Yeah.
Very
well,
strict.
It had to be, didn't
Yeah,
it?
exactly. Men's
People's-
lives depending on it.
Absolutely, yeah. Betty and her fellow workers gave up their weekend to try to break that world record.
Here comes the test pilot, Gerald Winnie, a really amazed man. He was planning to fly the bomber this afternoon. But so fast has this aircraft been completed that they got him out of bed to put the bomber through its paces.
It was wartime propaganda at its very best, aimed to bolster spirits at home and put the wind up the enemy. So did they break the record?
The record? Yes, they broke it, those workers. They said they'd build a bomber in their spare time in 30 hours. Its wheels lifted from the ground in exactly 24 hours and 48 minutes.
Well, I wonder if that thing got off the ground. I'll never know. I really don't. Yeah. There we are.
Yeah. Broughton has a long history of producing aeroplanes. In 1949, the Hornet took to the skies after de Havilland took over the site. The Heron was built in the 1950s, and the Beaver and the Chipmunk were also built in Broughton. Some aircraft became flying legends, like the Mosquito and the Comet Mark IV. This sleek silver plane was the fastest airliner of its day to cross the Atlantic. Now then, this is the most modern production area of wings.
Yeah.
So, and I couldn't let Betty leave without a glimpse of the latest wings. And look at all of this here. Just go to this barrier. You're right.
Yes, wonderful.
Yes.
Wonderful.
That is one big piece of material. It's not put together in any way, it's just made like one piece. And that is the bottom of a wing there.
That's as big as a Wellington bomber would have been.
It is, yeah. Gee. But there's no one stitching fabric in here. But
thank goodness. Oh, what a job. Unbelievable.
Can't help but be astonished by Betty's story. You can imagine all of those young girls and men learning these incredible new skills in this, strange place, building bomber aircraft at a ridiculous rate. Quite incredible, but we should all be thankful that they did do it. Our Welsh wing is beginning to take shape. With the top skin fixed on, it's time for the next phase of work to take place. And how things have changed from when I started out as an engineer. As a woman, I was a rare sight in a male-dominated world. But here at Broughton, I've seen more women engineers at work than ever before. One of them is Bridie Welsh, and she's the expert when it comes to the skeleton of the wing.
Underneath, what you've got here is your spar, made of carbon fibre.
And this goes the whole length of the wing?
Whole length of the wing.
Yeah, to provide stability.
Exactly. And then we've got our ribs in between.
Yep.
So what's interesting about these is they're made from aluminium instead of carbon fibre because the loads, the forces are quite complicated.
Bridie and her team designed the complex internal structure of the wing. That's because these wings do more than just lift the plane off the ground. They're also the fuel tanks for the aircraft.
Fuel tank starts right at the centre
Yep.
And moves out to around about rib 28.
And how much fuel did the wings take?
It's just under 100,000 litres.
Is it really?
Yeah.
It's massive, isn't it?
It's a lot of fuel.
Yeah. And when the bottom is on, the fuel is actually touching up against this, isn't it? Against this aluminium. So how does that operate? Do you have fuel pumps that take it through?
What we have is baffles. They're little holes within the ribs which allow the fuel to move throughout the rib base.
Without it just being one great big slosh,
Yes.
I suppose.
Yeah.
Right. So, when you go out on the town, do you go into Chester?
I do.
Okay. And the lads chatting you up, beautiful young girl, and they're going, what do you do? When you say I'm an engineer, what do they say?
I do get a bit of a shock, yeah.
I'm not surprised. Older commercial aircraft have up to 8 fuel tanks. The A350 only has 3. One tank is under the main body of the aircraft, while the other 2 are in the wings. Between them, they hold enough fuel to fly from London to New York and back again. Just coming up through an inspection hatch. I'm inside the wing now. The big end, if you like, of the fuel tank. Lots and lots of ribs stretching a long way in that direction. It's remarkable to think that this will be sealed and the fuel inside here will go through the pumps and so on into the engine, and no one will ever come into here again. So many people working on this. Hello? Our wing is nearly complete, but first it needs a good clean. It's transported to this huge hangar where they look for the tiniest bit of debris that may have been left behind during its manufacturing. I'm meeting local woman Beth Pickering, who's one of the youngest managers on the site. So Beth, there are these FOD signs everywhere, foreign object debris. So none of it's allowed through there.
Nothing is allowed into there that isn't already accounted for on our sheets. So I'm going to have to ask you to empty your pockets of any personal belongings, keys, phones, and put them all into this locker here. So anything that we don't need.
So anyone's working in this area, they've got to get rid of all this stuff.
Yeah, so anything that we don't need on the aircraft, we decant into what we call our FOD lockers.
Yeah.
Any tooling that is needed, we account for on the sheet, so it's signed in and it's signed back out, and this ensures the security of the wing.
Brilliant. Okay, am I allowed to go in like
this?
Yes.
So now we can walk into the FOD area. So if I just pass you this way.
Right.
So what we're going to do is just clean an area to make sure that the cleanliness.
Okay. So if I wanted to clean under here, I can't actually see that. So
yeah. So this is why we use a mirror, just to make sure that we can get a continued look around all of the products, so you can see every single.
Yeah, I know. It's not like being
angle
at
and
home,
area.
is it? Because you can't you're quite restricted in how you can move.
It is. So the mirror is really important to make sure that we don't miss any part of this bay when we're doing an inspection, so you can see every angle.
Yeah. Oh yeah, I can see it's picking up. So how small, because I've got quite a bit there already, how small an object would you be looking for?
So we're looking for the tiniest of fibres. So when we're doing this clean and this inspection, we're looking for any of the residue from the manufacturing processes.
Yeah.
We were also doing trials and tests with our suppliers to get our wipes to be as low linting as possible.
So they don't leave fibres behind.
So even the
either.
wipes that you're cleaning with don't leave fibres.
What are you like when you clean your house?
It's spotless. It's to the same standard.
Right answer.
It's ingrained in you when you've been on the shop floor.
Yeah. So, after several months in production, the 32-metre wing sits on the factory floor. Tomorrow morning it will leave Wales and head towards the south of France. It's the end of shift, and I've heard from my new buddies there's a celebration around the corner in the social club. From the bygone days of Vickers Armstrong, de Havilland and British Aerospace, veterans and ex-workers are getting together to celebrate 75 years of aircraft production at Broughton. I've been invited along, and there's no mistaking the pride still felt by the people here tonight. Everyone, in their own way, loved working here.
We were sheet metal workers, and we were like a big family. Honestly, it was like a big family.
I worked in the plan room, giving all the drawings out to the men when they came.
Members of your family have worked here then? So
Oh yes, my sister, my brother-in-law, my late husband, my son, myself, my daughter-in-law, the whole family.
Everybody. I've been admiring all these black and white photographs that are around.
Which are mine.
Which are yours, I know.
30 years I was in charge.
Were you? Of an archive, was it?
So
yeah.
it's all out. I didn't realise you were a North Wales girl.
I'm a North Wales
Flinty
girl. Born and bred. And our Betty's having a lovely time as well. An absolutely beautiful evening, but it's time to go to bed. I've got work again tomorrow. This site never rests. Our wing is preparing to take its first flight. Today it's leaving Broughton and is being transported to Toulouse in the south of France. And it's catching a lift on the strangest looking aeroplane you will ever see.
Beluga, because it's shaped like a whale, a beluga whale. Look at that high forehead. It's like a normal aircraft with this huge bit attached to it. It's absolutely stunning. The company's got 5 of them, and it's used to transport various pieces of a new aeroplane to Toulouse, where they assemble all the wings and the fuselage and everything all goes to Toulouse. But just that is extraordinary. Oh, what a privilege!
The last and most critical job of loading a wing onto the Beluga is down to the team with a tiny bit of help from me.
Are you ready, boys? We're going forward.
Keep that on firmly, unless I shout stop, just let it go, because it might have a fault with the aircraft.
You spelt forward wrong.
I fly above the
And I've literally only got inches on each side to play with.
Can you see how close the edge of the wing is there to the aircraft? And at the other end, this is the widest part of the wing, the root, you know, the bit that attaches to the fuselage. I just guess.
This is a big plane. It's the company's workhorse. But despite its size, it can only carry one A350 wing at a time. I've managed to squeeze on board to help deliver our wing. After a 2-hour flight, the Beluga touches down in Toulouse in the south of France. It's here that Airbus receives thousands of parts from suppliers in Spain and Germany, and the construction of the aeroplane begins, just like a massive Meccano set. Our wing is now carefully unloaded and transported, ready to be attached to the fuselage of the A350.
The site here in Toulouse is 5 times bigger than Broughton, and about 25,000 people work here. But look at this. This is where they start to assemble this fantastic jigsaw puzzle. So you've got the fuselage, the main body where we sit in an aircraft. Then you've got these beautiful wings all the way from Wales being attached. You see the tail fin going in, the horizontal tail plane, the landing gear. It's all coming together, and it's all been done quite quickly. So how many Welsh boys and girls are working in Toulouse then?
We've got about 50 altogether.
Yeah.
So we've got design engineers, map engineers, also got production, operations, quality.
It's exciting, isn't it? And you, a boy from Mould,
I know.
coming to work
yes.
in Toulouse. Did you ever think you'd end up working in something like this?
No, it's exciting times for me. I've been here for 7 years now,
Yeah.
with family, and I'm still excited. I enjoy getting up for work, I know, yeah.
See how beautifully that's milled there. Isn't that lovely? It's lovely work.
It's excellent, yeah.
As Paul and I get to know each other, we realise we share a surprising link.
I did a course once on milling and lathing in Wrexham Tech.
Very good.
Yeah.
I've been there myself.
You were at Wrexham Tech?
Yeah, a long time ago.
Yeah, well,
in the 80s.
mine was a bit further back than
well,
yours.
early 80s I was there with Wrexham Football Club, and they used to send us 1 or 2 days a week.
Yeah.
Because it's only across the way, right next to the racecourse ground, so...
Yeah. So we operated in the same grease together then, is that right?
Yeah,
it was quite dirty then though, wasn't it? You know, when it was all stuff spilling out everywhere.
I think it's gone a lot more high-tech now.
Yeah. It's a lot of inspecting to do, isn't it? From the time the wing arrives to when the fuselage comes and it's all fitted. So there were, what, 5 test planes built?
There was 5 test aircraft, which are on flight test.
Yeah.
So they do all the different tests that they go through.
Yeah.
It's a good feat, especially when the first one of these went up last year. It was...
Did you see it?
Yeah, we were excellent, yeah.
When it flew from here?
Yeah, we were all outside
First
here.
test flight?
First test flight,
Oh, how exciting is that?
Everyone was pushing up.
Yeah, we were all pedalling.
Well, no, it was a sense of achievement, really.
Yeah.
Until this point, the A350 had never flown. So imagine the pressure on the test pilots as the whole world looked on.
100. Positive 5. Gear stays down.
Getting the chance to step inside these extraordinary manufacturing sites makes me realise just how clever we humans can be. I've been told when the paperwork accompanying the aircraft is as heavy as the plane itself, they've got things right. So, when we jump onto an aeroplane to go on our holidays, most of us just take the whole thing for granted.
This is my
My first look inside the fuselage. Oh, wow. That is stunning. I've never seen anything like this before. I mean, you can see the insulation, all the different coloured insulation. That's to keep us warm as passengers and to stop the noise from coming in as well. And then all the seats go in here. You can see some of the tracks already laid down. This is 67 metres long, the whole fuselage, which is, if you take an Olympic-sized swimming pool, the length of that, and then you add on about 17 metres, about 50 feet, that's how long it is. And this flies over oceans. It's extraordinary. So where are the wings? Well, they're fixed in between the doorways. So you can see here that they're front of this door. And doors to manual. And the second set. So anybody sitting here is sitting alongside the wings, and you can see them flex beautifully in flight. And the detail, I mean, everybody working on here, of the electronics, of the air, I mean, just everything is actually quite extraordinary. But this actually, first class or not, is the best seat of all. It's these. Look, hello, bonjour. These people are working on the cockpit. Finally, our second wing has arrived from Wales and is being attached to the fuselage. To finish it off, there are a couple of very important pieces of French finesse to be added. And here they are. These are called winglets. They're like a French extension to our Welsh wings. They're made of the same material, carbon fibre, and they make the wings look distinctive, elegant, graceful, cool, if you like. But that's not why they're fitted. You see, what happens when the aeroplane is flying, you have a much greater static pressure underneath the wing than you do on top. That's how you get lift, that's how the aeroplane rises. But the problem comes at the wing tip, because when these two different pressures of air come together, they create mini tornadoes behind the aircraft, vortices. That creates what's called drag or air friction. And what that means when you're flying a plane is that you need more power to go at the same speed. And if you need more power, you need to use more fuel. To solve this problem, engineers turned to nature for the answers. This is a tawny Indian eagle. For millions of years, birds have been the perfect flying machines. Airbus employs engineers to study nature, to learn valuable lessons from animals and birds. It's called biomimicry engineering. By studying how this beautiful eagle flies, they have unlocked the secret to the problem of those vortices. Isn't he stunning? Yes, you. His wingspan is around 2 metres. And he is a bird of endurance because he has to stay on the wing for hours on end looking for his prey, and he can only do that by using as little energy as possible. Now, the A350 engineers have been studying effectively the ruthless efficiency of his wings and using that natural technology or elements of it in the design of the aircraft. So we're going to use, yes we are, and you're going to behave, a slow motion camera to record him flying and then play it back to you, and you can see exactly what happens. Dr. Norman Wood is an expert in aerodynamics who's been studying the performance of this bird to improve wing design in new aircraft.
It's magnificent.
Beautiful bird, isn't it?
Yeah, it's a very good example. Really perfect aerodynamics.
So, an eagle, built for endurance, has to fly on the wing for very many hours, doesn't want to use too much fuel.
No.
Its own energy,
That's
in
right,
fact.
yeah.
And it's exactly the same principle that's replicated with the wings of the A350.
Yes, well...
Light, with a composite.
It's the very light wing. It means we can adopt some new strategies because we're now using the carbon fibre.
Yeah.
And we couple that with this more detailed understanding of the specifics of the wing shape to get the minimum drag we can. What the Eagle has managed to achieve is the perfect match between a very light, efficient structure and a very efficient aerodynamic shape, with the tips slightly turned up to reduce drag.
Just as the A350 has the winglets?
Just as we've done on the 350. Yeah. And you can see the similarity straight away when you see the shots of the Eagle as it comes towards us, how it mimics, well, no, we're mimicking its shape.
Absolutely, yes. It's not mimicking the A350.
It got it right several thousand years ago. It's still with us, so it must be right.
It must be right.
And as we've evolved over 40 years of Airbus wings, you can see innovations coming in, not just in the way we've adapted the shape, but going beyond that to see how the bird actually controls that shape, how it controls itself in flight. And we're now adapting those things into the wings on the 350 as well, so it reacts to its environment. Maybe not quite as effectively as the Eagle, but we're getting there.
And when he's coming into land, flaps down.
Flaps down, wheels out.
Wheels out, gear down.
Eyes on the target.
There's a good boy. There's a good boy.
The new design of the A350 wing reduces fuel burn by 25%. And over half of that saving is by adding these small yet ingenious winglet devices. It has a huge impact on the environment, a greener and more efficient flight, thanks to the Eagle. It's remarkable to think that a whole A350 plane takes just months to build, from a jigsaw of individual parts from factories all over Europe. And here it is, the first aircraft they've designed and built, which is more than half, 53% in fact, carbon fibre. And I'm standing under one of the incredible wings all the way from Wales. And you think inside the journey in terms of the story that wing has made. You know, we've got the ribs in there, we have the spar, we have the stringers. It's just stunning. And of course, right at the very end, the upturned wings of the Eagle, the winglets, which make this aircraft so incredibly efficient. But one of the best things of all for me is that I get to be one of the very first passengers on board the prototype. This is one of the 5 A350 test planes to be built, and it's still being used by engineers to test the aircraft to its limits. And where better to go than straight to where I feel at home, the cockpit. Peter Chandler is the chief test pilot at Airbus. He was the brave man who took the very first A350 to the skies in 2014. Some impressive displays here, Peter. What are you testing in that first test flight?
That first test flight, in fact the first 2 flights, we were what we call opening flight envelope. So the normal flight envelope, that's from the low speed to the high speed and from low altitude up to high altitude. Just checking the handling of the airplane so that we could actually identify the natural characteristics of the airplane.
What element of the wings has made the most significant difference, do you think, to the A350?
I mean, the design of the wing is state-of-the-art in terms of the aerodynamics. And the fact that we have the ability just to very slightly extend flaps during cruise, so it's basically changing very slightly the camber of the wing, only by maybe 1 or 2 degrees extension of the flaps.
And this is interesting because the control column is over to the right here, to the left.
Yes.
If you're the captain.
Yes, since the mid-80s with the A320, we've had these side sticks as the means of controlling the airplane.
Do you like flying with them?
I find it very comfortable, and it just cleans up the cockpit so much. You've got a nice clear view. And of course the other advantage of having the side stick, if I could just show you, is that it allows us to have a table which has two modes. We have a keyboard in there which is the interface which we can use for example, typing requests for weather, and perhaps the more important setting is that which allows you to eat very comfortably, which is a major concern for all airline pilots.
Ladies and gentlemen, in preparation for takeoff, please fold away your table. Ensure your seat back is in the upright position. Thanks a lot for your attention.
We're taxiing out to the runway now, and the pilot, the captain, has changed the curvature of the wing. So he's put the slats at the front down slightly, the flaps at the back down slightly, and that means that we can take off at a much lower ground speed than we would without this happening. And that's because it provides greater lift at a slower speed. So now, here we go. Off we go, full throttle. He needs to get to what's called the speed of rotation so that he can pull back on the stick. The wings will lift us into the air. It's going to be beautiful. A350, Welsh Wings. So quiet, the engine, I'm sitting right next to the engine, and up we go. How beautiful. It's very quiet inside. I've got my decibel counter here. It's showing around about 75, 76 decibels, which is, well, if you consider that a normal conversation is around about 70 decibels, that's not bad. But the beauty of the two engines here and the whole configuration of the aircraft is what's called the noise footprint outside. So, you know, when you're sitting at home and you live near an airport, how noisy is the aircraft when it's taking off, particularly when it's at full throttle. And generally, with this aircraft, it's so quiet that the noise footprint is held within the boundary of the airfield, which is astonishing.
I'm not in the cockpit. I'm in front of what we call the flight engineer station. From that station, my job is to conduct the test. So, of course, I'm not able to handle the aircraft because I have no stick, I have no thrust levers.
What kind of things would you be telling the pilots to do?
So the first test we have to do in the first month after the first flight is to do what we call stalls. We have to stall the aircraft, which means that we have to bring the aircraft to a given point where it does not fly anymore.
Okay,
so
that isn't, because a lot of people when they hear stall, they think of their engine in their car stalling. It's nothing to do with the engines. This is all to do with the wings.
Exactly.
Yes. Finding the aerodynamic stalling point is one of the most important safety characteristics of any aircraft. It's something every pilot has to learn to recover from, but thankfully, Stefan isn't going to be doing it today. Setting the VORs and,
Like the needles, it's much more difficult.
Yes, absolutely. Do you really like flying this plane?
Oh, yes.
Do you?
Indeed. It's a very beautiful plane and it handles very well, so all the pilots are delighted to fly it. Yes.
This is where my story ends. It's been an experience full of surprises and unexpected discoveries. But my full appreciation of how much goes into building an aircraft has only just begun. I'm back in Broughton, and sadly the time has come for me to book my own takeoff slot and fly off home. This airfield has been at the cutting edge of aeronautical engineering for 75 years, and it had a golden age back in the 1940s. But it seems to me as though it's now within a new golden era. It really is at the forefront of aircraft design on a global scale, and it's fantastic because it's where I grew up, in Flintshire, in North Wales.
Yola Williams looks at the decline of our wildlife and habitat over the last 50 years and asks, what can we do to restore it, saving the land of the wild, next here on BBC Two Wales.